to go at things from a completely different angle, you argue that natural gas is our bridge to the future, and I can totally understand that based on my environmental science class, but there are alternatives to fracking in terms of getting natural gas. Cows and termites actually produce a lot of the greenhouse gases that we're currently dealing with, and those can be harnessed as natural gas and used as a fuel source. So, crudely put, would cow farts be an alternative?
Well, some things come to mind, but I'd rather not describe them publicly. If you could figure that out, it'd be wonderful. There are natural gas sources from decaying organic matter from dumps and other things, and those are being used beneficially, and there's no reason, not to use them. But when you're talking about the scale of the energy system, it actually turns out that livestock in general is an important source of methane, and as population has grown and as we globally eat more meat, it is an important source of methane in the atmosphere. Methane in the atmosphere is a bad thing, and we have to control the sources as best we can. But running the world's economy on cow flatulence is a tough thing to accomplish. Over here.
You've mentioned natural gas and you've mentioned methane. Are they in fact the same thing? And if they are, was natural gas named by the same committee that named Greenland?
I don't know who named it. The great majority of natural gas is methane, CH4. The natural gas liquids, the places where it's being produced in the northeastern United States and South Texas, you also get butane and propane, but they're basically gases in the reservoir, and they condense as they're being produced and separated. And liquid hydrocarbons, are $100 a barrel, so that's what makes it economic. The gas price is so low, companies really aren't drilling for just plain old natural gas anymore. I think we're on this side.
Well, thank you. This is very informative. I'm curious about the water issue, and you're saying about the scarcity of water not being so much of an issue if you're using a saline. How much water is actually being used to pump this, and where's that saline water coming from?
Well, if you drill down almost anywhere on Earth, you go through a region in which the cracks in the pores are saturated with fresh water. And if you keep drilling, that water gets saltier and saltier. And the reason is the deeper you go, the less that water is in active exchange with fresh water, with rainwater and other surface water sources. And that water gets salty because over geologic time, the water is interacting with the minerals in the rock. And so it tends to sit there for a long time and get saltier and saltier over time. So saline aquifers are very common and very widely distributed around the world. They're not everywhere. If you drill to Yosemite and you drill down, you hit granite, and you wouldn't hit a saline aquifer. But they really are very common. And so the point I was trying to make is that while traditionally any one of these operators would prefer to use fresh water, there are often other water sources. One of the biggest environmental problems that's not addressed is the cumulative impact of drilling so many wells in an area. Regulators know how to permit a well, they know how to permit a road, they know how to permit a pipeline. But when you're talking about hundreds and hundreds of wells and roads and pipelines, what we don't do a very good job of is sort of the equivalent of urban planning, coming out with a blueprint that private companies can operate within, but would overall, minimize the environmental impact. And one element of that kind of urban planning effort would be water management. Where's the water going to come from, and what are you going to do with it when you're done? And that can be done a lot better than it's been done in the past. And I think that'll go a long way to relieving fears that hydraulic fracturing is competing with consumers or competing with agriculture for fresh water supplies. It doesn't have to do that, but it has in the past.
Somewhere I've ingested the idea that lots of little earthquakes are better than the big one, and the belief that small earthquakes can relieve some pressure. So is there any thinking going on that the types of small earthquakes this process produces may have an offset of its risks in the reduction of potential other earthquakes in these areas? That
Yeah, not really. The amount of energy that's actually released out of the rock is so minuscule that, yes, it releases some energy, but if you add it all up, it's unimportant. A magnitude 4 earthquake releases 1,000 times as much energy as a magnitude -2, which is, if I can do it right, 1,000 and another 1,000. So a magnitude 0 is 1,000,000 times smaller. Magnitude -2, right, is 1,000,000,000 times smaller. So you would need 1,000,000,000 of these earthquakes to get rid of one magnitude 4, which is not problematic. What magnitude 4 would be widely felt but would cause no damage. So
then the issue is more psychological than physical?
No, the issue is more the issue is the physics. They don't release enough energy to do much good.
My understanding, but the concern about earthquakes then, given the scale that you've just talked about, is...
Yeah, well, to date, the earthquakes haven't been big and problematic, but someday they might be if they're injecting, again, next to the wrong fault that could potentially produce a big earthquake. So far it hasn't been a problem, but I think it could be a problem in some cases, and we want to be proactive and prevent that problem from happening before it does.
Thank you.
So they're not always going to be small, is my fear. Over here.
If you include oil shale, we have something like 200 years reserve of hydrocarbons. Is that considering the total amount of hydrocarbons that are under there, or the 5% that's recoverable?
The 200-year number referred strictly to the recoverable natural gas. I didn't say anything about total oil supplies.
Okay.
But if you read in the paper that the U.S. Is going to be energy independent by 2015 and all that, that's because we're producing oil from all those green areas that were shown on the map. So, a few years ago, we were importing 12 million barrels a day. We're now importing about half of that, okay? And the idea is we're going to be importing that much less a couple years from now, because there's just so much of this, already known but bypassed oil because it was, previously was uneconomic. So I haven't projected that into the future, but that's how these news stories about energy independence come about.
Okay.
Over here.
Appreciate you're going through all the reasons that all the safety concerns can be mitigated, but I think denigrating the politicians who are trying to see how to deal with the other side of the bridge that you're talking about is pretty important, since we know that there hasn't been a single human new venture that hasn't degraded the environment, and by enabling fracking, we're encouraging more of it, and we don't really know what some of the unexpected consequences would be. So a moratorium is an opportunity to try to foresee some of these and deal with them, and the politicians have to do that. That's what they do.
No, I disagree. Every industrial process has environmental problems. I totally agree. And everyone has unintended environmental problems. But, what's true of the automotive industry, what's true of the aviation industry, what's true of food processing, I hope somebody was paying attention when this water was bottled. I've been drinking it all afternoon. Okay? We have a modern industrial technological society that has to, have a regulatory system to deal with these issues as they arise. And so moratoria get you nowhere except by making a political statement. If you don't like the oil and gas industry, that's understandable, but nonetheless, it's not a solution. And a statement that we need a moratorium simply doesn't address what the real issues are. Now, I don't, think that oil and gas development, should be done on the parking lot of SRI in the middle of Menlo Park. There's some places where, while something that's being done is not necessarily harmful, you just don't want to do it, right? I mean, would you put a Safeway distribution center there, right? With hundreds and hundreds of trucks every hour, 24 hours a day, coming and going, coming and going. Of course you wouldn't. There's nothing intrinsically dangerous about that, But it's not an activity you would do in a populated area where all the impact would be felt. That's how I see the problem. You need to use common sense, you need to use right regulations, and you have to use enforcement of the regulations. And this industrial process, like many others, can be done safely. We've done it too many times. The world's not come to an end after 150,000 horizontal multi-fract wells. There are problems. We have to figure out what caused them, and we have to stop them from occurring in the future. Over here.
I wanted to bring this back to California a little bit and talk about Monterey Shale. I heard lots of good things, that there's a very large resource space over here that could be developed. But then just recently, I think within the last 2 weeks or something, I saw estimates from the Energy Information Administration bring that estimate down by 95%. I don't have the absolute numbers, but something like, so from 100 going to 5, is it still worthwhile? And if that's the kind of swing to be expected from this emerging field, what do I make of the 2,000 trillion cubic feet that is there and 200 years of supply that we talk about? Could that be vanished?
Yeah, well, I think the issue of the Monterey and what its ultimate capacity is to be determined. I think we simply need to develop the Monterey in a way that's consistent with the interests of the public and environmental protection. And so if you want to drill, the private sector is going to figure all this out, right? If they can't do it economically, they're not going to do it. And the public, needs to prevent the Monterey Shale from being developed in downtown Los Angeles, right? And just because the Monterey Shale is there doesn't mean it should be drilled. So, you just have to use common sense, and this thing's going to play itself out. The city of Los Angeles has passed a moratorium, and they made their political statement. The city council of Santa Cruz have passed a moratorium. They've made their political statement. But nonetheless, I am absolutely convinced that the Monterey Shale can be developed in an environmentally responsible manner in some areas. And in other areas, whether it's the geology and the faults that are present, or the population centers, or the fragility of the environment, you just don't do it, right? It's not black and white. You make a logical assessment of every case based on the factors that are operative there.
Thank you, Mark. I thought that was quite a balanced presentation that you gave. My question really follows from what this gentleman just said. I was going to ask approximately the same thing. I was going to ask you that on that first slide, you show a small green blob, which shows that there's oil being fracked in California along the coastline somewhere. I was wondering if you could describe that particular play and how is it going. And then I'd like to comment on the numbers that this gentleman was talking about. The numbers in the Monterey Shale, the original estimate was, I believe, 13.7 billion barrels of oil initially estimated, and that got down to 600 million barrels. Yeah. And I just wondered if you could comment on how that happened.
Sure. I heard about that when I was overseas, and I found it curious that the reassessment was so dramatic. And I haven't taken the time to chase it down. There are a couple things about the Monterey. First, it is often located in populated areas where development, shouldn't be done for obvious reasons. The second is that the geology is often complicated in Western California because of the faulting and folding that occurs due to plate tectonics. And so you can't drill these long horizontal wells. And so I don't know, what process the EIA or whomever did the estimate went through that factored in, okay, well now let's take off the table the fact that it's not going to be developed, in downtown Los Angeles, and now let's take off the table the places that in some places the geology is just too complicated, or that, it's not going to be economic. This horizontal drilling is expensive business, and if you can only drill a few hundred feet instead of a few thousand feet and stay in the shale, it may not be economic. So they had some process they went through to come up with such a dramatic reduction in the resource. But it frankly doesn't affect me very much. I'd like to see it, every well that's drilled, drilled in an environmentally responsible manner. And over time, we'll see how much the Monterey produces.
Well, could you comment on the little green blur?
Yeah, this is
Coastline
a
there.
figure I got from the Department of Energy, and I'm not quite, there are a number of things that aren't on here, areas in West Texas that are being developed and other areas. It's a largely complete map, but it's not perfectly complete, and I can't actually tell you much about that particular green blob. Can we take just 2 more questions? One over here.
I had a question about your solution for groundwater contamination.
Okay.
It seemed like you were just adding more pipes around the pipes. And I was just wondering if you could talk a little bit more about that and about how those will fare in the future, because it seems like the wells will be there indefinitely. And so what will they look like in 50 or 100 years?
Well, that's a good point, and that's in fact, we have to think about short-term and long-term protection. And one thing you have to remember is as the wells are produced, the pressure goes down. And so as a function of time, fluids tend to flow from the surrounding formations into the shale, not out of the shale. So the real problem, are the buoyant gases, and that's what we have to prevent. And so the steel casing is important, of course, but the cement behind the steel casing is very important. And whether you're drilling a Macondo-type well in the Gulf of Mexico, which blew out and caused the Deepwater Horizon tragedy, or you're talking about these wells, the secret is to do a very good job and to and we know how to do it. It's just not always done, of putting multiple steel casings and multiple cement up the annulus such that we have multiple barriers. Some amount of methane leaks out of wells. Every oil-producing region knows this. It's not what's been demonstrated is it is a problem, but it's not a huge problem. The real leakage problem is through the distribution system, and that's where the big leaks are occurring. But you're right, and this is just another reason why we want to move away from fossil fuels. We just can't do it fast enough without disrupting the global economic system, national security issues. Remember, we're kind of unimportant in this game. What North America and Europe do is really not important. What the developing world does, that's where economic growth is, that's where energy use is, and that's where the environmental impact is going to come from in the next 40 years. And I'd like to minimize that environmental impact as much as I can. India, highly dependent, almost 100% of its electricity comes from coal. It's going to start importing more coal in the next few years if it doesn't import gas. I've talked about China enough. So this isn't perfect. I'm not trying to say it is, but we have to make the best choice we can with what we have available to us. Okay, last question.
Okay, I've received several reports that Halliburton has developed a system for recycling fracking water, and that it's being marketed and used in places outside of Pennsylvania. Are you aware of that program and what they're accomplishing?
Well, that's right. But all the service companies have done that. They've moved toward green drilling technologies and green fracking fluids. I spoke at a conference last year, just after the president of Western Hemisphere Halliburton Operations, and he stood at a podium like this, and he had this green fluid in here, and he actually drank it. I'm glad. It makes you glad you're not the president of Halliburton. But you're absolutely right. And all this attention on the fracking fluids, these fluids are much more available. A few years ago, they were adding diesel, antifreeze to the water. It really wasn't the fracking fluids that was causing many problems, but there's no reason for that. And there are plenty of alternatives, and it's been important that a lot of public scrutiny and a lot of public pressure has led them to use these cleaner fluids, and hopefully that'll be done much more widely in the future. Okay? Thank you very much.